Okay, I'm just waiting a bit for some of the others to rejoin us again, and then we will continue. Guys, please confirm that you can still see my screen.
Yes, sir. So we can.
Okay, Napume, I think for you, if you have anything to say, please type it in the chat, because I realized that your mic is tripping. Maybe your internet connection is not that good. So please type it in the chat. That way I can at least respond to you as well. All right. I think most of you are back. Is there anybody who has the answer to what do we call those lines over there? Tracy, I see you are talking, but your mic is muted. Tracy?
Sir?
What do we call these lines that are highlighted over here?
Sir, I don't know.
Okay, not a problem. So we normally, whenever you see this two lines here, we call this, we want the absolute value. Okay, so we are referring to an absolute value, and I spoke about the absolute value before. The absolute value basically only tells us that whatever your answer is that you get from calculating the magnitude, it must be a positive number. Means your answer over here must be bigger than 0. Okay, it must be bigger than 0. Or if you to make it more mathematically correct, you can say it must be bigger than I don't know now which one to put in except a -1. It must be bigger than a -1, but it must not be negative 0.2. Okay, that's why I say it must be bigger than 0. But for those who just understand integers normally, it must not be basically any negative numbers that you get will be wrong. Okay, so it must not be a negative number. So that's basically what those two lines represent. It means we must get a positive answer for that. And this is why we attempt it with that get the differences squared and then root it. So when we root it, our answer on the calculator normally comes up to a positive answer. And that is basically what we want. So that's how we would basically calculate a magnitude. And let's just see some examples in calculating a magnitude. All right, so I will be going through this a little bit step by step and explaining where we need to explain. Imogene, I'm going to mute your mic quickly. Okay. So before you look at all of this writings here, all right, it's very important that we spend some time on the image. All right. Look at the image. You have to spend time here. You don't need to go to questions and just try to answer. We first try to look at the image, see, do we understand what's going on here? Yes or no? And then we proceed to the questions, all right? If there's things that we can fill in, then we fill in the things already in the diagram or in the image here, and then go to the questions, all right? So over here, I see I have S, so that means point S is starting over here. I have T, that means that is the point for T over there. There's a line joining them, and then there's a vector indication of them. All right, so if I ask you in a test, which one of this one is the head, which one is the tail? Who can give us the answers? Which one is the head? Which one is the tail? Trust me, this is a very important exercise because we are going to talk about head and tails a lot. So which one is the head? Which one is the tail?
T is the head and S is the tail.
Okay, thank you, Rishua. T is the head, S is the tail. Very important to note. Okay, if I may ask you, Rishua, how did you come to that conclusion that we have? And Chance is having a question. Go ahead, Chance.
Never mind.
Okay. Rishua, do you mind explaining us how did you get to head and tail?
Because the arrow is pointing in the direction of T. So if you were to put the arrow at T, if you were to move it up to T, it will show that T is the head and S is the tail.
Okay, thank you for that explanation. And I also answered your question in the chat. We are basically having a Google Classroom where we will put up all the notes are also going to be published there. And everything is also going to be posted there, the links to the videos and so forth. And the rest can share with you via WhatsApp if you are on one of the groups as well. And your answer is 100% correct. That is basically what we have. The arrow, the head points to the head. And obviously, if it's the head, then the opposite will be the tails, all right? That is a good way of representing it. And so when we are representing this, because there is no small letter, all right, we will be using T and S to represent our vector, which is what we have over here, all right? So we say, okay, vector ST has the following things. We have 6 and 7, and the 6 that we have here, okay, and this, sorry about that. The 6 and the 7 that we have over here, I just want to talk a little bit about that and also about the images that we have. So in our image over here, you will notice that this is a graph paper. However, we do not have any coordinates assigned to it. So you don't know where your x-axis and y-axis is. And I would like to spend some time on this because it's very important for us to understand what is going on here, right? So let's say our x-axis and y-axis was the orange line over here. And the vector was now somewhere over there, right? This is now, in some questions, you note that we will combine everything together. I keep repeating in the classes, I said, whatever you are learning, it's like a multiple chain effect. Okay, what you learn today, tomorrow you will use in a question, and it continues until you finish your university. If you continue studying, right? Mathematics is still there for all the courses, it's compulsory. So if this is our x-axis and y-axis, and now let's say we get a scale that says that one block represents 1 unit, and if this is our center 0, right, then this will be -1, and it will go on like that, okay? And this will be, after 0, we'll have a 1 over here. This will be a +1 for the y-axis, and this will be a -2 for the y-axis, because this one will be -1 over here. Okay, now I want you to follow as much as you possibly can, because I will be explaining what is going on here. Where did that 7 come from? Where did that 6 come from? That is what I'm explaining now, okay? If you're following with me. I hope this makes sense, all right? Good news is most of the time we will give you a vector that does not have coordinates in, but if we do give you one with coordinates in, then we still expect you to know where 6 is coming from, know where 7 is coming from. This 6 and 7 are normally represented by a U and a V, and this U and V is also most of the time what we use in physical science, physics terms, when we are calculating vectors in physics. Okay, they are common terms for physics, but for mathematics, let's do the calculation. All right, so let's look at the coordinates for S, since we now have a x-axis and y-axis. Let me just define my This is my y, and obviously this will be my x over here. Okay, so I know I'm explaining long, but it's what I have to do so that you can see the whole picture. So the coordinate for S will therefore have a coordinate for x values. It will be -1, 2, 3, 4, 5, 6, 7, 8, 9. So it will be -9. Okay, -9 for the x value for S, and the y value will be -1, -2, -3. So the y value is -3. Okay, that is the coordinate for S. All right, then we have a coordinates for T. All right, T will now have 1, 2, 3, 4 for y, and -1, -2, -3 for x. Okay, -3. And for y, we said it will be 1, 2, 3, 4. 4. Okay, so excuse me about that. So basically in this case, what we have here, you decide now which one will be your y1s, y2s, x1s, x2s, and so forth. And after you decide your x1 and x2 or y1 and y2, then we try to basically get the differences, the sum of the differences for the two of them over here. And then we basically square them and then square root them. And then that is basically what we are trying to achieve. All right. So if I just take the x coordinates for both of them, the first one is -9, right? Then you will say -9 minus the other one, which is -3. Okay. So -9 minus 3 will give me -6. Okay. And remember, we said that for vector things, we always want positive quantities for this value. So this will normally be an absolute value that we will try to get, okay, out of this. So this will be an absolute value, means you just take the positive number of this, and the positive number of that will be a 6. And that is where you see the 6 over here, as that 6 is what we get from our x coordinates. All right. Same for the y. If we do y, I'm just going to use a different color for y quickly. So y, we have -3 over on this side, and then we have minus, the other one is a positive number, it's a 4. And together it will give us a -7. And remember, in this case, we are concerned about positive numbers most of the time. And if you get the absolute value of this, you will just get a 7. So that's where the 7 comes from for the y. Please note my x and y's. This was the x value, this was the y value, this was the x value, this was the y value. Okay, so that is where the 6 and 7 comes from if we are using coordinates. Okay, it doesn't matter where you put where the y-axis and the x-axis starts. As long as you have the coordinates, you can get those two values, the 6 and you can get the 7. All right. And we represent them as the x will always be on top and the y value will be at the bottom. So that represents the whole vector. Okay. I'm going to clear that now, and then I want to talk about the other way we do it. So I know now you can at least see this 7 and 6 where they came from, right? Remember, the horizontal line represents the x-axis, so this will be our x values. Not make that x a little bit nice, and this will be our y values. Okay, so another straightforward way we normally do it, and I'm going to use a block for this, is you just count the blocks, or we try to basically create a sort of a triangle. It doesn't matter if the triangle is facing downwards or if the triangle is facing upwards. So we try to connect these 2 points over here. So what we do is, for the x values, you will count the blocks like this. Starting from here to go to that end of the triangle, you'll see it's 1. Let me just use the yellow color so that we can mark it out. This is 1. That is not... very nice marker. So that will be 1, this will be 2, this will be 3, 4, 5, 6. So 6 blocks. That is like the length of this vector, okay? Like here, length, breadth. Now that's what we are trying to do, or breadth, length, whichever way you are looking at the triangle. So that's where the 6 units comes from, okay? And we do the same thing for the y. We count the values. You can start at top. It will go down 1, 2, 3. Let me just mark it also. 1, 2, 3, 4, 5, 6, and 7. That's where the 7 units comes from. Whether you drew the rectangle or triangle, excuse me, at the bottom, or if you go use it here at the top side, you will still get the same answers. So S is starting from here. It will be 1, 2, 3, 4, 5, 6, and that's the 6 for S, and then for X, and then the Y values will start over here, 0, 1, 2, 3, 4, 5, 6, 7, and that's 7 for the Y values. So using the block methods, we can also calculate that. But it's not always the case where you will have your grids or your blocks that you will have. So we try to avoid making it so simple for people just to count blocks, because at your level, we don't need to tell you to count blocks. We need to see if you can work something out mathematically. All right, show your skills. So that is basically how we get to those units representations that we have here. If you remember that we got the same answer here using our coordinate system, right? The change in Y and the change in X, and you will notice that this square root symbol that we are getting is again just trying to find the absolute value of what we have here. There are also rules. The rules are that if we are going, and I will explain that. On another slide that we will have. But let's just quickly go through this one. How did they calculate the magnitude? So column vector and its magnitude, the displacement from S to T can be achieved by moving 6 units to the right, 7 units up. I explained that. Or you can also move 6 units to the left and 7 units down. It doesn't matter. That will be the vector, but I will explain to you why it is to the right and up. And then we use Pythagoras theorem to calculate the magnitude of the vector, and it's given by this formula. So please note the following. We still have, yellow is not a very good color. We still have the following. We still have the square root, right? And remember the first value we said was our X. And if you remember the distance formula, we had the one that was given by, who gave the formula? We had x2 minus x1 bracket squared, right? So that bracket squared, that what we did, that x2 and x1, that's from the coordinate system that we got, plus, and then we had our y2, right, minus y1, and we had it also squared. So this y2 and y1, we saw that we got a 7 or minus 7 in the other example, but when you squared it and square root it, we'll still get the same answer as in this form, because that protects us, this absolute value method protects us from getting negative answers here. So it's exactly the same thing, except that instead of having x2 and x1, we just have a normal u value, replacing the 6, which is already like calculating already the difference between x1 and x2, and the v calculating the difference between y2 and y1. All right. In physics terms, the physics students will understand exactly what I'm talking about here. But for the accounting students and the commerce people, it's a little bit difficult. So that's why I'm explaining it in grassroots level type of form, right? So it's exactly the same thing that we are doing. Don't get confused. when you see examples in the textbook or other places. In the textbook examples, they just talk about your x squared plus your y squared, all right? So that is a simplified version. In physical science and those science fields, they talk about u squared and v squared, okay? That is the difference. But remember, the x is actually that change in x, and the y is the change in y that we are basically squaring up, right? I hope that makes clear. Is there any question here before I proceed? Any questions, or can I proceed?
Proceed, sir.
Okay. So let me proceed. We all have about 10 minutes or so left. So I hope I can complete this to get to the question. So in this sense over here, what I just did is explain exactly to you what I did in the other side. And this is now giving it in a more scientific view, where we have a column vector A is U and V, right? Change in X, change in Y. And then the magnitude will be the absolute value of A, all right? The positive value of A, which is now the size as well, where the distance is a positive number. And then we have that U squared plus V squared, and we root all of them together. And we already explained how we get to this part over here, all right? So if I proceed, this is some of the questions that we might also encounter. But before we go to the questions, I would quickly like to explain something very important as well, right? So over here, I have my Cartesian plane, and I would like to show you a few things that we need to look at. All right. So okay, so I'm going to use different colors to quickly denote anything. For some of you who remember trigonometry, or if you go to trigonometry, you will get this what do we call it? Quadrants. Quadrants that we call casts. Okay. So at the A, everything here is positive. Okay. It means the X is positive, the Y is positive. Okay. At the S, we notice that the X is negative and the Y is positive. So that is for your X. This is for your Y. Okay. At the T, we notice that the X is negative and the Y is negative. That is your T. And at the C, we notice that the X is positive and the Y is negative. That is your X. That is your Y. All right. So knowing this also helps us, very important. So we have vector representations over here. So if there's a vector going in this direction, the vector can also, sorry about that. The vector can also go in that direction, or the vector can be very close to the line, all right? As long as it's in here, then your column vector for your X and your column vector for your Y will all be positive numbers, all right? They will be positive here, positive here. That's how we will represent this vector when it's in that direction. So here it means we are moving to the right-hand side. We are going right for X. X will be right, okay? That's where the right comes from. And Y will be up, okay? So Y is always either up or down, and X is either left or right, okay? In the other side, on the other hand, towards the other side, if the vector is going in this direction, or the vector is going in very close to the Y in that direction, Then this side, we will still have our X and the Y. And we said that our X will be a negative X over here, and our Y will be a positive Y, okay? Because the Y values are going up. You can see this vector here is a little bit lower, but you will see that the Y is increasing in positive numbers. And the other one, it's already showing you it's increasing in Y, but the X is increasing in or decreasing by negative numbers over here. That's why we get this here. So the X here will be left, okay? And the Y will be up. Okay, this is now the orientations that we are doing. It can also go in that direction, it doesn't matter. These are all position vectors because I'm starting from point origin, all right? But it does not need to be only position vectors. It can also be a vector over here. It doesn't matter where it is located, as long as it's in that direction of the S in our cast, okay? Then we have the other two directions, which you can also see what's happening now. So if it's going in this direction, that way or so, or even if it's here, it doesn't need to be at the origin, right? Then we know that our X will be negative and our Y will also be negative, all right? That's in the T direction. And if they go into the, direction of, let's use gray, C in our cast, okay? Whichever way it goes in, all right? Then we know that for this, our X will be positive and our Y will be negative. And you will note that this X will go right, okay? And the Y will go down. And this one, it will go left. And the Y will go down. Now, why am I putting up these values over here is because you will now automatically and immediately be able to identify by looking at your X value and your Y value in which direction your vector head is pointing. All right. When we are going to be doing vector additions and vector subtractions, then you will need to see, okay, if I add this and this together, if my X value will be negative, which direction will my arrow be in? Then you already know, oh, my arrow will go in this direction for negative X to the left. If I add the Y and the Y and my answer is positive, then I know that, okay, instead of down where it's negative, my positive Y will be in this directions here. Then you can accordingly or correctly draw in the vector representation of your calculation. All right. And this is an important part when we are going to deal with vector addition and vector subtraction. All right. So I hope we will always come back to this example. I will also share this example with you guys because this is a very important thing that we need to do. We are dealing with vectors. We will always have calculations for X and Y. Those are numbers. But for directional purposes, this is what we use. Where is the direction that it's going into? How do we know it's going into that direction? Okay. Right down, left up, right up. And we use our cast as well. So again, I'm putting cast in here because this is our quadrants. This is our first quadrant. This is our second quadrant, and this is our third quadrant, and this is our fourth quadrant. And if you also note that most positive things are indicated here, and this is normally where we have our bar graphs, histograms, and so forth. And if you include all the quadrants, that's where you have your pie charts and your pie representations of the things that we have here. All right. And for those Gantt charts and all those other things, we are using both of those things. So I'm also trying to give you an indication, where is these things in real life again? You will find them. It's just most of the time they don't tell you that this is, oh, this is what you did in high school. This is what you are supposed to know. All right. They don't explain it in that way. They just accept think that you already know it by heart. All right. we only have about 10 minutes left. So let me go to the next point, which I wanted to show you, and that would be our question. Is there a question?
It's the like for like okay to find the gradient. Okay, the formula was is like y2 minus y1 divided by x2 minus x1. So can it also be y1 minus y2 divided by x1 minus x2?
Sorry, the last part, when you you cannot put the for the gradient.
Yeah.
The gradient formula, repeat it again.
It's
Delta y over delta x.
X, yes.
Yes. So we for that gradient of the graph, you cannot put the x variable on top. Okay.
No, like sir, I mean like can it be okay since it's y2 minus y1, can it also be y1 minus y2?
Yes. It
So
doesn't
it can
matter
be both.
because yes, it can be both.
So
You will
I want
still
to
get
give
the
a
same
different
answer.
answer.
No.
Okay, sir. Thank you.
Okay, that will be the same answer for everything. All right. I will be able to again explain that to you later on if you like. Please note, I will post this is going to be the homework that you guys need to do. It's basically a quick exercise. You just write down what is the column vector for this given vector over here, and the other ones it will ask you to draw in the vector. You can draw it in at any place, it doesn't matter where you draw it in. And here at the bottom we have two vectors that we want you to draw in, and here there's two vectors we want that we have. There's a space for one. If there's not enough space, just add on the other side as well. And this part as from here on, right over here, this is going to be a vector addition, but we did not do it yet. We're going to do it in the next lesson. Vector addition and subtraction as well. So over here it's a sum of vectors. So we haven't done this yet. We have only covered for today lesson section A. So only answer section A for today. If you feel confident, you can answer section B. All right, I will be sharing this on the Google Classroom as well. And remember that if you want us to check your answers, you can take a screenshot of this and upload it. Now, I have also explained to some of you that you can use Adobe, the app that I showed you in the previous video lesson, that those apps allow us to at least add comments or things like that as well. All right. That is it for grade 11. Thank you, grade 11. I'm going to end this session, and so that the recording can be stopped, and then we will upload this as well. Next lesson will be tomorrow, same time. Thank you.